So we are going to continue our discussion about basic polynomials in 7.1 from class today, and we're going to be looking at different ways to model real-life situations like area and volume using polynomial models. So the first problem we are going to look at is to write a variable expression for the area of a square. So we have area and square, whose side is x plus 8. So if we're not quite sure how to do that, we're going to first draw a picture. So we're going to draw a square. We know squares have 4 equal sides and 4 right angles, okay? And we know a side is x plus 8, and since we know all the sides of a square are x plus 8, that means this side is also x plus 8. And we know to find the area of a square, you do length times width, or side squared. So using that formula, our area model for this square would be x plus 8 all squared. And if we want to write a variable expression, we're going to expand it. So we're going to have x plus 8 times x plus 8. And then multiplying through, multiplying all of our common terms, we're going to get the area is equal to x squared plus 8x plus 8x plus 64, which means that our area model is going to be x squared plus 16x plus 64. So what we could use this model for is that means any value of x that I give you, you could instantly substitute into this expression and find the area of the whole square. The next type of example deals with a little bit more complex of a rectangle. So we have the length of a rectangular window. So I already know I have a rectangle and I know I'm probably going to want to draw a picture, so I'm going to go ahead and do that so I can label while I read. Draw our little right angles in here to show it's a rectangle. Okay, so we have the length of a rectangular window is 5 feet more than its width w. So that tells me that w is our variable for width. And we know our length is 5 feet more than the width. So we know that that's going to be w plus 5. So we'll let this be w, and then our length is going to be w plus 5. The area of this window is 36 square feet. We want to find an equation that could be used to find the dimensions of the window. So we are also told area is equal to 36 feet squared. Okay, we know that the area of a square or a rectangle, whatever box type thing you're looking at, is length times width. So we know that our area is 36, and we know our length is w plus 5. And our width is just w. So to find a good equation, we want to get this into a form where we could solve for it. So we're going to distribute our w through here and have 36 is equal to w squared plus 5w. Now because this has a highest exponent of 2, that means this is quadratic, and we know to solve a quadratic equation we want to get it equal to 0. So we are going to subtract 36 from both sides of our equation, which, moving up here, we're going to get 0 is equal to w squared plus 5w minus 36. So that would be the equation we would use to solve this. Now, we are good mathematicians and we are very curious about what this value of w would be, so we're just going to go ahead and solve it for some practice. So if you want to solve a quadratic, of course you have a few different ways of doing it. You could use the quadratic formula. I'm not going to repeat the quadratic formula, you should know that by now, or you can factor it. So I'm going to factor. So I like to use kind of like the guess and check logical thinking strategy for factoring. So I know I need to have two numbers that multiply to negative 36. I'm going to go off to the side here. So I need to multiply to negative 36. But then I need to add to positive 5. So I need two numbers that multiply to 36 but give me a difference of 5. So since 36 is negative, one of my numbers has to be negative, and since my sum is positive, 5 is positive, I need the bigger number to be positive. So if I'm going through my list, if I'm not quite sure, I might make a list. So 1 and 36, okay, can't use that. 2 and 18. Nope, not 5. Okay, I got 3 and 6. Okay, I could get 3 as my difference if I subtracted. That's closer. And then if I try the next one, 4 and 9. Hey, 4 and 9, I can get a 5 out of that. And since I want a positive 5, I have to do negative 4 plus 9. Now, since my a term in front of my w squared is 1, I know that my factors are just those two numbers. So I'm going to have 0 equals w minus 4 times w plus 9. So to get my two solutions, I have to set each factor equal to 0. And then solve for w. So here I would add 4, so w would equal 4. And then I would have to subtract 9 for the other one, so w would equal negative 9. Now, if I go back and look at the context of the problem, w stands for a width. So we can't measure in negative numbers, which means that my negative 9 is not a possible width. So that would tell me that the width of my rectangle is 4 feet. And then if I use the expression on my box, I could also tell you now that the length is 9 feet. Which is good because 4 times 9 would give me back my 36 square feet for the area. So we just went a little further than the problem actually asked us to, and we went ahead and found the dimensions just versus finding just the equation. Okay, so we have this new type of problem. We have a length of a rectangular box is 6 inches longer than its depth. The height of this box is 2 inches shorter than its depth. And our goal is to find a polynomial model. So we want to write a polynomial for the volume. So I know we're talking about a box and its rectangular prism, so I'm going to go ahead and draw a box. Please do not laugh at my drawing skills. Okay, so we got a little three-dimensional picture going on. Close enough, right? Okay, so we got a box. We know that volume is equal to length times width times depth for this box. So we're going to go ahead and have to write some variable expressions for each of those. So if we look at this, our length is 6 inches longer than its depth, and the height is 2 inches shorter than its depth. So both the height and the length are based off of the depth. So I'm going to let x equal the depth of my box. So depth is going to be this one. So if my x is depth, that means the length of my box is 6 inches longer than its depth. So that means my length has to be x plus 6. And then it tells me the height of the box is 2 inches shorter than its depth. So that tells me the height of this box has to be x minus 2. So now all we have to do is substitute those three expressions into our volume formula over here. So we're going to get that the volume of this box is equal to length was x plus 6. Width, or I guess this should be a height here. Whoops. So length times height times depth. That just sounds awkward, but those are the letters we're using, okay? So we have times x minus 2, and then our depth was x. So if we want to find a nice polynomial model, we're going to go ahead and expand this expression by multiplying them together. I'm going to multiply my first two binomials together first. So I'm just going to show my little multiplication lines here. So I'm going to get that the volume is equal to x squared minus 2x plus 6x minus 12, all of course times x there on the end. Combining my like terms, I get x squared plus 4x minus 12, all times x. Go ahead and distribute my x term through my parenthesis sets. So my final polynomial model for the volume is going to turn into x cubed plus 4x squared minus 12. So again, since this is a model, it now means if I gave you the value of x, or if I told you how deep this box was, you wouldn't have to go through and find the length and the height as well. You could just instantly plug into this model and come out with the volume. So all of these examples have been building to something like this. So we have a piece of metal, so a piece of like sheet metal that's 24 inches by 20 inches, and we're going to make it into a box by cutting out squares of size x from each corner. Okay, that's a lot of information in one line, so let's break it down using our picture. So we have this piece of sheet metal over here on the left-hand side. We're going to say it's 24 inches by 20 inches, so this side seems to be longer, so I'll put the 24 across my length and my 20 inches on the width. And we're going to cut it into a box by cutting squares of size x out from each corner. So that means each of these little squares have a side of x. So I want to figure out the volume of this box. So they provided a picture of a three-dimensional box over here. So I want you to imagine cutting those squares out and then folding along the dotted lines and making a box out of it. And if you're having trouble just visualizing it, grab a piece of paper and go ahead and measure this out. Cut 4 squares out from the 4 corners and then fold it into a box and see what happens. So if we go ahead and do that, if we were to physically do this, the height of our box here would be the distance of these squares. So this height is going to be x. So the height of my box is going to be x. So now originally the length of my rectangle is 24, but I'm going to take away these squares of size x. So I have an x on this side that I'm going to cut away from my 24 and over here. And we know that when we take something away, we are subtracting it from the total. So I'm going to take my 24 inches for my length, and I'm going to subtract 2 x's off of it because I'm subtracting that x square on both sides. Same thing with my width now in this box. I'm going to cut away an x down here and an x down here. So this is going to turn into the depth of my box here instead of the width. So we're going to have 20 minus 2x along the sides. So then just like we've already found a volume model before, we are going to do, it wants us to call it v of x for our volume polynomial. We know we're just going to multiply our 3 dimensions together, so I'm going to do x times 24 minus 2x times 20 minus 2x. And so of course we're going to go through and expand it just like we've been doing. So my v of x polynomial, I'm going to multiply the x in last and do my 2 binomials first. 24 times 20 is going to be 480, so we're going to 480. And then 24 times negative 2 minus 48x minus 40x. And then negative 2x times negative 2x is getting me a positive 4x squared. Okay, combining my like terms and continuing, we're going to get 480 minus 88x plus 4x squared, and then distributing my x term through, I'm going to get that my volume polynomial v of x is really 480x minus 88x squared plus 4x cubed. So I could leave my answer as that, except that it says I want to give my answer in standard form. And we know from class that standard form means that we have to write it in descending order of our exponents. And my highest exponent currently is a 3, which means that this is a cubic polynomial. And that means we want the 4x cubed to be at the front. So we're going to do v of x is really 4x cubed. My next highest power is my negative 88x squared plus 480x. And that's going to be our final answer. Okay, so the rest of your homework assignment is to complete your 3 on your own or OYO problems. So you want to first write a volume model for the box shown below. So given those dimensions, then you're going to find an area model for a rectangle and then an area model for a triangle. So you're going to have to make sure you know how to find the area of a triangle for that one.